Today I will be doing a walkthrough on the badRansomware forensics challenge hosted by HackTheBox Business CTF 2021. This was a fun and interesting challenge as it involved a Word document containing obfuscated macros, which we needed to de-obfuscate to be able to retrieve the flag. So to start us off, let's just review the challenge information. So it states a wave of phishing emails came in today to see that seems to be executing some kind of bad ransomware. The triage team said they created encrypted copies of all the files in our downloads folder, but forgot to delete the originals. Oops, anyways, see if you can take a closer look and find the flag. So to be able to start, we'll just need to download the files, which I've already did. You can see once extracting the zip file, you're left with a badRansomware.docm file. So to be able to start analyzing this file without potentially infecting ourselves, we'll use a tool called OLE tools, which just googling OLE tools, you can navigate to the GitHub to get the installation guide, and you'll just run this installation command. I've already done that and I have it installed on my machine. So once installed, we'll just run OLE ID followed by the file name to get some information regarding this file. As you can see, this gives us some valuable information: the file format, containing format, encrypted, VBA macros. Yes, it contains macros. Does it contain any XLM macros? No. We can see we're dealing with some VBA macros inside this Word document. To be able to extract this, we can see we can just use the tool called OLE VBA. So we'll just run OLE VBA followed by the file name. So to be able to start analyzing what this VBA code would do, we'll just copy this out into Sublime. And then just saving this as stage1.vbs. We can now start analyzing what this VBA code will do. So first we can see it sets the function auto-open, which means it will automatically execute this code once the document is opened. And then followed by a bunch of sleep 0 statements, which just means it will sleep for 0 seconds. So essentially it will do nothing. So for now, we'll just replace all of those sleep zeros with nothing. Also just removing extra new lines. You can see we're left with this, with the remaining script. Just following line by line to see what it does. I can see a lot of repeated TAN functions with different variable names each time, but it seems to be following the same format. Setting the variable to a random string, setting two variables to random strings, setting the first one to a random number, and then setting the second one to a random number divided by TAN, that first variable. And we can see this is repeated throughout the script. So it follows the same template. So essentially we can see this variable name called somewhere else in the function. And we can see it is literally only called twice, only being called when it was set. So this will be set to a random number value and never called again. So essentially all of these TAN functions we can just remove. So I'll then just start removing these TAN functions, if I can call it that. And also just, again, replacing all unnecessary new lines. And we can see we're left with this remaining script. Also just one more I missed. And I think we have all of those. So we can see we're now left with this remaining script, which I'll just save. And then just for better readability, I'll just run this through a VBA formatter. To get the indent. Now I can see we have somewhat of a more readable script. It's still very obfuscated, but we'll start de-obfuscating it now. So we can see first we'll set this random string variable, which would look like it's gonna get the shapes of the active document, followed by this name, and then get the alternative text of that, which I'll circle back now to. You can see it sets this random string variable, which will then be set to 3 @, and then called here. So we'll just replace this with 3 @ and remove those extra part. Also see we'll set another random string variable equal to 0 and then call it here. So we'll just replace that with 0, remove that part. Also getting another random string variable, setting it to the U bound of whatever this variable would be, and then calling it inside the for loop. So essentially what U bound will do, it will just get the length of the array. So for now we'll just replace this string variable with length of array. And then we can see it sets another variable which looks like this is going to be our PowerShell command, where we can see it's going to bold up the command string, and at the bottom part we can see it kind of spelling out PowerShell for us. So we can go ahead and rename this to our PowerShell command. And going further, we can see it sets another variable, which would then get the first element of the for loop. And also another variable which looks like it's going to get the char value of whatever this variable is going to be. So for this, I'll just rename this as char value. And we can see it's going to bold up the PowerShell command with whatever that value is going to be. And then we'll just rename this as array value. So the next step would be finding out what this variable is going to equal to. So we can see it will call the active documents and get the shape. I'm assuming this is going to be our shape name, and then get the alternative text of it. So to be able to retrieve this, I'll just open the document to see what we're dealing with inside. Just getting the warning message, this document contains macros. The execution of macros is disabled to the current macro settings. So just saying LibreOffice will not execute the macros contained in this document. So once opened, we can see we have 2, which looks to be file of image files. Right click on this and just go into the properties of the image file. We can see the file name is equal to this random string variable, which looks familiar. From our script, we can see it equal to that. Then we can see the description is a random obfuscated string value, which we can then take that value and replace it here. Also go into the second image, doing the same. You can see the name is equal to that random string variable, which we saw here. And then just getting the description, replacing it here. So now we know what this variable is. We're going to call this obfuscated command. So now going through the script, we can see we'll set this obfuscated command equal to this, just then append to it, and then split that obfuscated command into an array, splitting at 3 @, which we can see it's going to split it into decimal values. And just getting the length of the obfuscated command array, looping that through a for loop, taking the values what is inside the array one by one, getting the char value of that, and then building out our PowerShell command, and at the end calling that shell and executing that PowerShell command. So to be able to de-obfuscate this obfuscated command, I'm just going to recreate this script inside Python. So to be able to do that, I'll just copy over the entire script and then change the syntax to Python. You can see it here. So the way VBA appends strings is with an and sign. So we'll just replace all the and signs with a plus sign. And then we'll just need to fix this split command. And then inside Python, we can actually for e in obfuscated command, which will just loop through each element inside that array. Go to next. Just save this as decode.py so that our syntax highlighting is correct. And we can just remove that. And as the for loop is looping through each element, it's going to set the first element to the letter E, and then the second one to E, and so forth. So we can essentially just remove this command and set char value to char. We'll just need to int the string value and that set it to E. And then in the end, just print out our PowerShell command. Running Control B to execute this inside Sublime. We can see we have an error. PowerShell command is not defined. So to fix this, we'll just set it equals to an empty string. Running that again, we can see we have some PowerShell command. We'll just copy this out and paste that into a new window and save this as stage2.ps1. So now the next step would be to decode this base64 string and see what that is going to execute in PowerShell. So to be able to decode the PowerShell base64, I'm just going to Google it. You can see it's just going to be running this command. So we'll just create a variable called x, set that equal to our base64 string, and then decode that variable. And we can see we're left with this following string. Saving this as stage 3 or PS1. And then I'll just do word wrap so it's all in one screen. And we can see it will invoke expression, then join the whatever this string is, and then split on those values, and then get the char of each integer value. So when running this inside PowerShell, I could not get this to work correctly. I think that is part of the challenge so that the actual command does not execute inside your environment. So looking at this command, we can see it will pipe whatever this value is going to be and then get the char of each integer. And then looking at this string, we can see we have some decimal values all split by a character. So to be able to figure this one out, I just assumed it's going to split whatever this string is into an array. It's going to split on each character inside this string. So what I did was just find x and replace that with a comma. I just went through the entire string value. And we can see we're left with an array of decimal values, which when decoded is most likely going to give our final stage. So I'll just copy whatever the string is into a new script and then just Control-Z to get our original script as we've overwritten some valuable characters. I'll just copy out whatever this last ending trail. And to be able to decode this, I'm just going to run this inside PowerShell, inside Kali. You can see our format is wrong because we did not include our quotes. So I'll just replace each comma with a quotation mark, comma, quotation mark. And just fix the beginning and end trail. And run that again. And we'll just copy the results inside a new Sublime window. I don't have infinite scroll on my Terminator. I'll just rerun that to be able to copy that, the entire decoded string. Could have probably joined the string again inside PowerShell, but my PowerShell commands is a bit rusty. I'll just copy that into a new window, and replace each new line with a blank space. And then we're left with our final stage. Call that stage 4.ps1. To start analyzing this last part of the script, we'll just do a word wrap, and we can see it seems to have a lot of obfuscation of the strings. Where we can see here, it will just append the string here, and also use this technique, which will also just build out the string based on the index value. So here we'll just get the index value of 1, which within this string is going to be the get the index value of 2, which is going to be 10, and then get the index value of 0, which is going to be t. Essentially, this will just spell out get content. So to be able to de-obfuscate this, we'll just execute the string parts inside PowerShell, and it should return us the string value of it. So for the rest of this, I'm just going to copy paste this into my PowerShell and replace whatever that string value is going to be. Also see here, it's going to be replace. I'm getting the char values. It's going to be KB3. We can see it's going to replace this string. It's getting a char value of 92 again, which is going to be a backslash. So we'll see it's going to replace where KB3 is with a backslash. So just taking that command. And I'm just adding our quotes. Removing the extra brackets, and we can see the value is going to be the following path. So now we can just replace all of that with our path. Just putting that in quotes as well. And just keep going through the script, replacing the obfuscated strings with the correct values. And we can see we're left with this de-obfuscated PowerShell script. Also just checking the base 64 here. You can echo that. And then just decode that from base 64. Tag T for decode, and we can see we're left with our HTTP flag. Confirming this is our flag. We can just submit that flag. And we can see we've solved the bad ransomware challenge.